This one is October 2022, paper 6. I'll discuss the full question. That's why I'm recording the session. Like I'll discuss complete question to even the parts which you have doubt or you don't have. A plant fertilizer containing a mixture of a sand and ammonium sulfate. The percentage by mass of ammonium sulfate in a fertilizer is determined by the procedure as shown. 5.75 grams of a plant fertilizer is added into a conical flask and 20 cm cube of a sodium hydroxide with a concentration 1 mole per dm cube. Ammonia is formed in the reaction. The flask is heated for several minutes to ensure that all ammonia formed is boiled off, means given out. The solution contains an excess of a sodium hydroxide, which is separated from the sand. And then aqueous solution containing the excess of sodium hydroxide was made up to 250 cm cube, use deionized water. And then out of this 250, we just take 25 cm cube sample and we titrate it with hydrochloric acid, which are concentration 0.05. The first part describe how all the solution containing excess of sodium hydroxide is separated from a sand in step 3. So if you want to separate the sand and sodium hydroxide will be aqueous, means it will be dissolved, like mixed in water. So what we should do, we should use a filtration. So the method which we use filtration, and then usually what we do, because like if you want to remove the soluble substance, so we wash the residue. When we wash the residue with the distilled water, so remaining, if any trace of soluble substance is there on the insoluble, that will also dissolve. Then describe how to make a 250 cm cube solution in step 4. So we took the sample and we want to make it. So for this, what we need a volumetric flask. So we will use a volumetric flask. We will transfer the solution and the washing. Like all the solution, and why volumetric flask is there? Because volumetric flask is having only one marking. So like 250 cm cube mark is there, so we don't get an error. So what we do first, we transfer the washing, like transfer the solution with washing, and then we add a deionized water and we fill up to the level. And then we just shake, like you can say, shake the, place a lid or a stopper, and then shake the bottle. That is how we make a solution, 250 cm cube. The mean titer was 12.75. Calculate the percentage by mass of ammonium sulfate in a sample of a plant fertilizer. Look, this one is the volume of hydrochloric acid. So in what we'll do, from hydrochloric acid, the concentration and volume will get the moles. From moles of hydrochloric acid, we'll get the moles of sodium hydroxide, but that moles will be in 25 cm cube. Then from 25 cm cube, we'll get the moles of sodium hydroxide in 250 cm cube. And from this 250 cm cube, we have the equation. So we work out how much ammonia gas will be there. So you have to, because if you see this, these are the moles of a sodium hydroxide which are there unreacted. So after getting a moles of sodium, because if you see this one, a conical flask contains 20 cm cube or 1 mole per dm cube. So this will be the total moles. And the one which we get reacted with hydrochloric acid and in our 250 cm cube, that is unreacted mole. So total moles minus the unreacted mole will get how many moles of sodium hydroxide will react. And from moles of sodium hydroxide react, we get the mass moles of ammonium sulfate, and moles of ammonium sulfate multiplied by mass in gram will get how much mass of ammonium sulfate is there. Is it clear? Should I solve? The mean titer. So using concentration into volume, we'll get the moles of HCl. like 12.75 divided by 1000 and multiplied by the concentration of HCl, which is 0.0, which was 0.05. So this will give us the mole 0.00063, 7 mole. Then the ratio between hydrochloric acid and sodium hydroxide is 1 is to 1. So we have 0.000637 moles. So how many moles of sodium hydroxide? It will be X. We get the same answer because the ratio according to equation is 1 is to 1. So we got sodium hydroxide. After getting the moles of sodium hydroxide, but these are the moles because we did not take full solution. We took 25 cm cube and we titrated with HCl. So these are the moles of sodium hydroxide in 0.00637 moles in 25. In 250 cm cube, it will be 10 times. So multiply, it will be 0.00637 moles. These are the moles which are unreacted because the unreacted moles were titrated. How many total moles were used for sodium hydroxide in the beginning of experiment? Like total moles were added. That is concentration into volume. So the volume was 20 and the concentration is 1. So this will be 0. So total were 0.02 and this were unreacted. So how many have reacted? We just subtract them. So 0.02 minus 0.00637. That will give us 0.013625. These are the moles which are reacted. And now you need the moles of ammonium sulfate. So if you check the equation, the ratio was 2 is to 1, like 1 is to 2. Ammonium sulfate from the equation to sodium hydroxide, it was the ratio according to equation was 1 ratio 2. So if we have 0.013625, so this will be X. Cross multiply, you get the moles, and then these moles multiply by the molar mass. You'll get the mass in gram. So 0.0136 divided by 2 because half will be there, multiplied by the molar mass 132. You will get about 0.89 grams. So the question is, calculate the percentage by mass. Like what is the mass of ammonium sulfate in the sample? What was the original sample? The original sample was 5 gram, I guess. So original sample was something like 5 gram, 5.75. So 0.89 divided by 5.75 into 100, that will give us the percentage of this ammonium sulfate in the mixture. In part D, a student carrying out the experiment did not heat the sample for long enough to, in step 2, to boil off ammonia. Explain the effect, if any, on the value of a titer, hence calculated the percentage ammonium in the fert. Look, what will happen? Ammonia is alkaline. So if a student did not boil off, like what student did, student boil off the mixture so that ammonia can escape. But what if he did not boil off? So what will happen? Some of the ammonia is still there. And what is the nature of ammonia? Ammonia is alkaline. So when we react, when the reaction is complete, we will have excess of sodium hydroxide, which is there. And we'll have extra ammonia is also there. So if we react with hydrochloric acid, if we titrate with hydrochloric acid, so we need more hydrochloric acid. If we need greater amount of a hydrochloric acid, so as a result, what will happen? The amount, because our idea is that like we are reacting sodium hydroxide, the unreacted sodium hydroxide with hydrochloric acid, the unreacted. So if there was a dissolved ammonia, so we need more hydrochloric acid. So if we need more hydrochloric acid in the mixture, there will be greater amount of unreacted, like it will appear that we have greater amount of unreacted sodium hydroxide. So greater amount of unreacted sodium hydroxide. So the reacted moles or reacted mass will be less. So as a result, ammonium sulfate amount will be lower. So if the ammonia remain there, then ammonia is alkaline. The points he will mention ammonia is alkaline. It will react with HCl. So the mean titer will be higher than expected. So as a result, what will happen if mean titer is higher? So we'll have a greater amount of unreacted moles of sodium hydroxide. So the reacted moles will be less, which reduce the amount of ammonium sulfate in the mixture. Is it clear? The reason why, if we don't completely react, like if we don't completely remove ammonia, then what will be the effect? State how the student could have confirmed that all ammonia has boiled off in step. So basically, like student is boiling, ammonia gas is released. So what student can do? Student can test this ammonia gas. How student can test this ammonia gas? So student can use a damp red litmus. If this damp red litmus turned blue, it means still ammonia is given off. If the damp red litmus does not change the color, it means there is no more ammonia gas. So student place a damp red litmus, and if it shows a color change, it just means ammonia is given off. If there is no color change, then there is no ammonia gas given off. Red litmus can react with ammonia, but we are not putting it inside. We are like red litmus is actually being clamped or placed above it. Solution, because sodium hydroxide is dissolved here. Sodium hydroxide is aqueous solution. But ammonia, what happened? Like when we heat, ammonia gas is, it's actually ammonium hydroxide because it mixed with water. But when you heat ammonium hydroxide can decompose into ammonia and water. So because of the heating, that ammonium hydroxide decomposed to ammonia and water, ammonia gas which is released, that will turn. But sodium hydroxide, it's actually not released in the form of vapor. That's why it does not turn. It can turn red litmus blue, but in this case, because it is not released as a gas or the vapor, that's why it is not turning it. So we are not putting the red litmus inside, we are just clamping or placing it above the mouth of the container or the tube.